All right, so let's dive in. Let me just share my screen. All right, we're gonna try this. Awesome. Okay, so and I'll be recording this meeting and sharing the slides afterwards. So don't worry. Of course, you can take notes. So there's just a lot, just based on my previous conversation I had with Thrishti earlier this week. So what I want to do is I'm just gonna go through the few slides I prepared, and then I would propose that we do questions at the end just to make sure I can go through the whole thing. It's kind of gradually increasing in complexity, just so you know. So we're going to start simple and then go all the way to more complex and modern stuff. But yeah, so thanks for being here. We're going to talk about search. I said search and personalization. There are some stuff in search that are personalized, obviously, today. We're going to touch on some of those concepts, but I'm not going to dive into personalization and recommendation because that's just a whole other a whole other topic and session because there's just so many things happening there. So the goal is really to go through what do we call search, kind of how it works end to end, the user experience, but also a lot of the back end, how it's working and how it evolved with more modern technique today, and like commerce, chatbots, and things like that. And then I'll also talk about the success metrics because usually as PM, that's what we like to know about. And then, of course, hopefully we have some time at the end for questions. So just quickly, a little bit about me. I'm Laure, originally from France, moved here in the US at the request of Expedia 10 years ago. I've been in I've done product for more than 15 years. What really got me into higher leadership positions was my ability to just break down really big vision and big project into clear, actionable milestone with a really fast time to market, which usually companies like. And then more recently, I actually quit my job and launched my own business. I do two things. I help women founder specifically go from an idea to actually launching it, making sure they have the right product for the right users, unlocking growth and revenue for them. And then I also help teams upskill and up their game from an efficiency standpoint. So I do a lot of things about AI right now, as you can imagine. And I've worked for both big companies, as you can see, and my last role was in a startup, a pretty big startup actually, OfferUp. So that's a little bit about me. In all of those years, I specialized in recommendation system personalization, 0 to 1 idea products and things like that. So that's kind of why I know what I know. I've been pretty hands-on. Okay, so search. When we look at it, I took Amazon, and I'm gonna have a few screenshots with Amazon because I think it's the easiest way to understand how search work and give actual visual example. And when you look at it from a user experience perspective, you're yeah, okay, there is a search bar, then I search, and then I get results, right? Simple. But behind the scene, it's not that simple, actually. And so here you have a very high level simplified view of kind of what's going on, right? So on the user experience side, you have the search bar. The very first step, which is the entry, is the autocomplete, which in itself is not a small thing. That's actually a pretty big feature for a lot of companies. Then you get to the results page. And then obviously what you're hoping to drive through search improvements is conversion, right? That's your goal. And then if you look at the back end piece of it, sorry, I'm a little sick. But if you look at the backend piece of it, there's just a lot happening in between those two steps that usually takes only a few seconds from a user perspective. The first thing is we're going to translate this query that the user provided into something that the system can understand. Then we're going to have the retrieval step, which is really taking the relevant documents from the index and then ranking it. So putting all the kind of like intelligence there to decide what's going to show first. And then usually there is like a personalization layer on top of it that helps filter and also re-rank the results that you see. So there's just a lot of step. And what I'm going to do today is just go into each of them so you can understand how each work. And also what are the things that you could do in each of those steps to improve the product. So the first one, autocomplete, that's like the entry point. I'll actually start by the bottom of the slide. Why autocomplete is important. Industry standard metrics, there's about like between 30 and 50% of users that are actually clicking on those suggestions. They don't even like type something. So it's a pretty big contributor to how people get into search results. That's why it's super important. From a backend perspective and like search team perspective, it helps simplify the request structure for your search engine. So that's also good if people take that suggestion. And from a business perspective, it helps you take the user where you want them to go. And usually you try to land them into search results that you know are going to be really good, right? You don't want to put them into a dead end. So how that step work, it's a predictive ML model. It's not really new, like it has evolved with time, but it's usually kind of the same logic everywhere. It's a tree-based data structure, meaning like as you start typing letters, it's going to look at the most likely next letters for you and then build the words. The ranking on what shows, like you could see here in my Amazon search, it really depends on popularity, seasonality. So that's one of the criteria for ranking. The other one that could be used is marketing. Let me just see. I think I have one more person joining. Sorry. And so usually marketing could also use those slots to drive people to certain, seasonal or marketing type of push campaigns. But yeah, usually that's what is in there. There is a layer of personalization. You could see here in my Amazon search, it shows me a product that I bought in the past that contains these letters.
So Laurie, I have a question about the marketing part. So
yep.
Is it where marketing or the business user are actually going into the search platform and kind of boosting certain words? Or do you mean just like they're just driving traffic based on certain words and then the search system is realizing that?
Yeah, that's more the latter. Usually it's automated. And you could see it here, I'm guessing, right? I never worked for Amazon, but just based on how it's displayed here in the auto suggest, I'm guessing electric scooter is a marketing type of push thing because it has the image of an electric scooter versus you see like electrolytes and all of those terms that have the search magnifying glass. So I think that's where you could see some of these things on different websites.
Hey, for what it's worth, my teams have worked on this specific feature, so I can say that this particular thing is not marketing driven.
Okay.
Without saying too much, but yeah, it's not marketing driven. It's really what experiments show as the highest return in terms of how people are using it. So if somebody starts with elec and it seems like electric scooter is what is picked most often,
yeah,
that is what ends up in the model over time. So it's a very dynamic kind of a thing, and this piece is not marketing driven.
Okay.
I see where you go, how you mean, like, some of these could be marketing driven or other things.
Yeah. Yeah. And that's what I was saying. Like, I know you joined kind of in the middle, but it's primarily popularity driven.
Yeah.
What I was explaining.
So in which part is it like keyword search, or is it like, predictive ML model? Is the search results already?
No, we're at the first step here. We're just auto suggest. So just the step of like you see suggestions. Hold on, we're gonna go to keyword search and all of that, okay? Okay, so autocomplete, that's the query that the user is typing in, and then we have all of those suggestions. Now, the next step, user selects something or finish typing their query, right? The very first thing that was done in search, and that's still done today, is keyword search. It's what we used to call the lexical era. And you could see this, to put it really simply, you could see this as a like reverted index. So remember in books, you had the index that was telling you some of the words and which page they were at. Here it's the opposite. It's like, I see the word, I'm trying to match with those words, and it tells me what are the things that corresponds to those words. So that's kind of what it is in a really like high level way of saying it. What the system is going to try to do here is matching exactly across different fields in your index. And I'm just going to do a little quick 1 second pause here. I talk about index, and I had this question in the past. When you think about search system, there is usually in a, let's say, e-commerce world, right? You have your database that has all of your products, and then you replicate a smaller version of that database, which is called index, and that's what we use for search. It allows you to only get the fields you need for search, not the whole database, which then helps your search system to be faster and being able to return results much faster. So that's what the index is. And so when we do keyword search, we try to match words across all of the different fields that we have in the index, or some of them, sometimes not all of them. And what it does really is kind of two things. With a request that's coming from a user, there is the term frequency, which is like, if this term is more rare, is qualified as like rare, it's going to high importance. And then it does the opposite with the inverse document frequency. A term that's often used going to have like no value, and it's going to ignore it. What that means is somebody who's going to be searching for the iPhone, it's going to take iPhone as the actual term that it needs to search on, but it's going to ignore the, right? That's what it means. So it's eliminating some of the words that it should not be considering. So as I say that, you could already imagine some of the limitation. But let's start with the pros of keyword search. It's super fast. It's literally just matching, and it's exact. So if you're searching for, L-shape electric desk, 63 inches, blah, 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 something really precise, it's going to be your best thing to do. It's going to be to do keyword search because it's exact. The cons of keyword search is, if I'm, let's say, searching for a couch now, it's not going to show me any results that I have that are mentioned as sofas. So that's the synonym problem, right? It's not going to return that because it's searching for an exact match. There are cases where there's just like missing keywords. So we see that especially now more in marketplaces, for example, where people will take a picture and give you very little description. The problem with that is like the words are in the picture, not in the description, so I cannot match, right? So that's another problem. One thing that has been done over the years now is that we're also extracting keywords from image, so that helps solve for that problem. And then there's the multi-keyword association. I talked about like, important word and non-important word. That becomes a problem in, let's say, brands. So Bed Bath and Beyond, like this thing needs to be all together. You cannot look at those terms separately because then you're going to have crazy results. So that's the multi-keyword association. That's also a limitation of keyword search. You could work with your search system and make it a little bit more flexible with that, but it's still kind of pretty limited. So I talked about query understanding. So just based on all the limitations we've seen with keyword search, one of the first things that different teams working on search tried to do was, okay, because I'm doing this exact match, I'm going to try to be better at understanding what the user is actually searching for. That's what we call query understanding. And sometimes we also call it the intent layer. You might hear that. That's what it is. And it's really, the technical term is named entity recognition. It's another machine learning model that's running on the query itself, and it's going to split it into different entities. And what it's going to do with those entities, it's going to classify it and apply some business rules, usually filtering, to determine what it needs to get from the index. So for example, if you're looking for cheap red Nike shoes, what it's going to do, like what it used to do with just simple keyword search and no query understanding, was trying to find the exact match. Likely that's not going to work. With query understanding, what it does is it's taking this query and it's saying, okay, cheap, I'm going to put a price filter below $50. Red, it's the color, so I'm going to try to match that with the color field that I have in my index. Nike is the brand. I'm going to try to match that with the brand field that I have in my index. And then shoes is the item category, so I'm going to only return results that are in this category. So that's basically how the query is translated for your system. And you have an example here with my electric L-shaped desk search. You could see the price that's mentioned. If I just change it to cheap electric L-shaped desk, then it applies a price filter for me automatically, right? So that's because there is this layer of query understanding on the top that determines and filter out some results based on what I've typed. Okay. So semantic search. We talked about the pros and cons of keyword. With all the limitation that we've seen, and even if we've been extracting keywords from image for a number of years now, the problem was the pure matching does not account for any kind of like broader type of search, which is what users tend to do now. It's like, unless they have a very set thing that they want to look for, usually searches are more like broad, or more like, I would call this like inspirational. They make reference to things that are not necessarily what they're looking for. For example, I want to dress for to go to a dinner. Like, what does that even mean, right? And so that's why the industry has evolved towards semantic search. Instead of doing matching, we're trying to understand the meaning. And so technically how that translates is that now in my index, I'm not going to have just like my items and fields with keywords in them. I'm going to have my index going to be like you could look at this like a map. And each document is going to be converted into a like coordinates, basically, literally like on a map. And each of your documents, which is like all of the items that you have, will be translated in coordinates. And those coordinates, that's what we call vector or embeddings. You might have heard both terms. That's literally what it is. That helps solve for synonyms, because if you look at if you think of your index as being this like map of the world, those coordinates will place couch and sofa close to each other, but it's going to be very far from like tire, right? So that's what vector or embeddings semantic search does for us. It helps us look at that map and say, these things are close together, so they're probably relevant. So I'm going to go a little bit deeper into what that actually means and trade-offs for the teams that are working on search. When we talk about search, we talk about precision. Precision is a metric that translates the accuracy or the relevance of the results. Okay? Recall is the other side, the other part of search, which is more like the breadth. How many results am I returning when I run this query? These became much more important metrics with semantic search, because now I'm not matching. I'm trying to find things that are close to each other. Like, we call this like I try to find my neighbors, basically. And so what this means is, with keyword search, when you were trying to match things, you only had a given set of results that would be returned. And then once the results were exhausted, that was the end of the search results page. Here with semantic search, we come from a totally different place, which is I'm trying to find all of the things that are close to my coordinate. And if you don't tell it to stop, it's going to return the entire map. So that's why precision and recall are really important, and are also things that you could play with when you try to improve semantic search. The levers you have for this type of search are one, the vector, the embedding. You could choose the size of it. So the size is going to depend on how much input information you're passing to create this coordinate. It could be just a text. It could be the text plus the image. It could be additional information about the seller who's selling this item, the ratings about this item. Like, you could choose to pass anything in that in anything to create that embedding. The higher, the bigger the size, obviously the bigger the cost, because with semantic search, cost is a huge thing to look at and be careful about, because vector database are much more expensive from a storage perspective, but then from a, what's the word I'm looking for? To read the embeddings and find the neighbors, like the actual search, also costs a lot more money because you need more GPUs. So cost is very important. The bigger your embedding, the bigger the cost. But if you have a really big embedding, the precision is going to be improved. So the relevance will be improved. On the other side, the recall, that's another lever that you have. You could say, okay, I want to try to keep my costs low, but I do want my users to see the most relevant results I have. So one thing you could do when you do the nearest neighbor search, you could determine how much results you want back. And so there are various opinions and implementations across different teams. You could choose to say, give me only the 10 best results, the top 10 results. The advantage of this is that you're going to have really relevant things, but you're going to have very few results. And so the consequence here is that you might be missing some items when you do that. When you go all the way the opposite and you say, okay, I want to see, give me the first 500 results. When you do that, you have way more results, right? So you very low chance to actually miss results. The problem, though, is that now you're going to have things that are much further away from your original query. And so when that happens, you might have related things to what the user is searching. And then the more you go into the results set and you go down the results page, essentially, the more you're going to have results that are not relevant. So these are the two kind of levers that you could play around with to try to optimize for both precision and recall, meaning you want the most relevant things at the top, but you also want enough results that the user can actually find what they're looking for. And all of that obviously has a cost associated to it. So it's something that usually you work with your engineering team just to make sure what is the most efficient for the users, but also from a business perspective, what's the most efficient from a cost and revenue perspective. Okay, so hybrid search. We talked about keyword, we talked about semantic. Both have their pros and cons. With semantic search, you will never be able to actually be super precise if somebody is looking for something very specific. Like my search here with like the Lego and the number of the actual set, like that is keyword search. You cannot, like, semantic just doesn't work for that type of things. And then when you're looking for gift for a 12-year-old boy, keyword search doesn't work, right? So both have their pros and cons, and that's why most companies have moved to what we call hybrid search, and they use both depending on the use case. And when they use both, they could choose two different kind of implementations or a mix of implementation, which is either with that query understanding, right? We have kind of a classification of what the query means. And so from that classification, we could say if somebody is searching for like a brand type search, I'm always going to do just keyword search because I know I'm going to return relevant results from my users. If somebody does a broad category search, for example, then I'm going to only use semantic search because I know keywords not going to be able to give me what I need. So that's one way of implementing. You completely split the two, and there is never a mix in the results. One of the things that most companies do today is actually a mix of both, where they would actually send two queries, one keyword search and one semantic search, and then they bring back both sets of results and they merge them. And so with that merging, there's just an additional step that happens, which is in both result set that are coming back, they have their own score, like relevant scoring, right? So for keyword search, usually we use one that we call BM25. It's going to give you a score between 0 and 100, I think. And then for semantic search, we use, there are different types, but most often we use constant similarity. It's going to give you a score between 0 and 1. And so what's happening is once you want to merge both results, you have to kind of normalize those scores. So you take all the relevant score from both results set, and we use what we call a reciprocal rank fusion method. We take the rank in both lists. We use a constant to kind of like normalize the rank, and that gives us a common rank where we could merge both lists and decide which one goes first, third, etc., etc. So it's a little bit more technical, but that's kind of like explaining that additional step. If you use both queries, then you have two results set that you need to merge. And that's why there is this additional step in terms of ranking to decide which one goes first. And here I said hybrid search is the modern standard, and I put standard in quote unquote because a lot of people are talking about it, but when you talk to companies, you'll see that actually there's very few that are there today. A lot of companies are still trying to figure out semantic search. So there's just, in the industry, there is a huge variability of where people are, and that's because search systems are very usually legacy. And so touching them, it's a very critical part of the business. So it's always complicated to manage these projects and do big technology shifts like this on a system like search. Okay, re-ranking mechanism. So once we do the search, whether it's keyword, semantic, we get the sets of results. Let's say we merge them. Now we have our list of things that we want to return to the user. The last thing that's happening before we show the results to the user is what we call re-ranking. And here it's another usually machine learning model that's on top, that sits on top of those results, and it's going to decide which product I'm going to show first. And in those ML models, they're usually like very complex and really big. because they are literally like the brain. They're going to decide what the users see. And they intake a lot of different signals. There are usually kind of 3 types that decides which order I'm going to show the results in. The first one is obviously relevance that we kind of talked about. That's how the results are actually organized before it goes through ranking. It's making sure we're matching the original query and intent of the user with what we're going to be showing. The second type of signal that is going into that ML model is the business logic. It's making sure that the user is successful. So we're going to show items that are, available. And then making sure the company is making revenue. Usually that's kind of what sits in that business layer. You could think of signals like, I want to show my high margins product at the top. I want to show my advertisers product at the top. I want to show products that only have a rating above 4 out of 5 stars. I want to only show products that are available. So these are all the signals that would go into that like business logic layer for the re-ranking. And then the last but not least part of the re-ranking is personalization. Personalization happened for every single users today. There are 2 ways. One is usually for new users, we use something called collaborative filtering, which is looking at what other users who search the same thing as you did on my platform in the past, and I'm going to inform what you're going to see based on that. And so I'm going to determine the likelihood of you clicking on this item based on what I know from other users that have done the same thing as you. And then the second one is more like for existing users. Usually you have already behavioral signals. So you know that like even if somebody says cheap Nike shoes, you know that they always look at the color red. And so you're going to kind of like supercharge red as a color into your personalization for that user. And you're going to show those results more at the top. Personalization is also used to filter out things. So let's say somebody's searching for a phone. They've always only looked at Apple phone. We're just going to filter out anything that's not Apple, even if it was returned in my set of original results. So personalization is used both for ranking or filtering sometimes. So the personalization product trade-offs, things to keep in mind. The first one is when you have existing users, like how long do you want to look back at their data, and how do you use this historical data that you have on them? What is the threshold you want to determine to say if this data is still relevant or not? Because if a user hasn't come back on your app since last year, like, does that actually make sense to use this, or should you just go and use collaborative filtering? So that's one important thing to keep in mind. And then the other thing, personalization model and just like re-ranking in general, he's a big step in search. That's one that actually takes probably the longest because it's a heavy model. It's really about finding what's going to convert the best, right? That's the success metric of this model. And so you have to determine what can be done offline. What are the signals that I don't need real-time insight on? So like, you would do a daily batch or something, or like, every 4 hours or whatever, but like, it's more like offline batch type of things versus the things that you need real time. Like in e-commerce, availability of a product, that's like something you need real time. Like if you don't want the user to get into that dead end, that's one of the signal you have to be real time. But like in that model, in that personalization, you need to determine what are the things that really you need to know now versus like if it's from yesterday, it's fine. And there's a move right now towards more real time, and that's how you see sometimes your feed is changing based on where based on what you're clicking, because they just save your your behavior right now. They save that on the client and they can readjust the ranking on the fly. So that's also, depending on what type of experience you're looking for. Cool. I think after that, we're going to be able to do some questions. So the last part is more kind of like what's happening right now and is becoming even more complex in the search world is anything around chatbot and more conversational commerce. And why is this different is because not only now it's kind of like more broad query, but it's also query that requires context across different dimensions. And so in order to enable that, we use a new thing because we like to come up with new names. We do what's called RAG, Retrieval Augmented Generation. And that helps with the multi-layered context understanding. So I'll take a very simple example. If you go, on Amazon or anybody who has a bot, you ask, is this dress, like the dress I'm looking at, is it available? Is it in stock in blue? And I need it ASAP. So what the system's going to do here, it's going to, with query understanding, it's going to understand that you're looking for that dress in blue. So it's going to go and find those blue dress. That's the retrieval part of the RAG. And then it's going to do augmentation, which means it's going to take those, let's say top, usually it's between 3 and 5 results. It's going to read the details. So color, the price, availability, shipping timeline, because I said I needed it ASAP. And then the information is going to be fed back into the LLM as additional context. So now it's going to have what is retrieved, my 3 to 5 items, all the information about these. I'm using that to then generate the response and provide a complete answer to the user. So like you could see, I asked a kind of a similar question, but about that desk, and it told me what colors were available, what was the brand, and which one I could get quickly. So it gets all this information because we augment the context it has. So there are 2 advantages with this technique. One, it helps make it a little bit more human and conversational. It's not just like yes, no type of answer. It's like I can give you even more than what you asked. And the second thing, it helps limit the hallucination of the models. Because if you just ask it, is this dress in stock? It doesn't have the availability information, but like any LLM, it's going to give you an answer anyway. And it's going to completely hallucinate probably. And so the fact that you're doing the retrieval first, like you have your set of inventory and that's a set, it limits that hallucination and gives you the actual information you need. So that's there's a lot of articles and blog posts that are around this right now because it's very much what a lot of the search teams are moving towards and working on right now. Whew. All right, success metrics. So a few metrics that you've probably heard about, but things that as PM and search are the things that are core to what you're measuring and how you want to show your impact, right? And that's then how you get promoted or hired. And so core primary metrics, it's first and foremost, you want to assess the quality of the results. Because when somebody's searching for something, you want to give them what they're searching for. And so there are 2 ways to do that. One is the negative signal, which is, are we failing to find things? So it's 0 search results rate. That one is very important. That's also, if you join a search team, that's also the easiest to act on usually. So if you join a search team and you see that rate being super high, find the queries it's high on and go tackle that. This is easy win usually. And then the second one is when we do return results, we want to understand if the top results were matching the user intent. And so, and how we do this is called the normalized discounting cumulative gain, which really is looking at the items that are relevant that the user clicked on and what was the rank of those items. And you want that rank to be obviously the highest because you want the most relevant things to be at the top. So that's the metrics that we're looking at to assess the quality. The secondary metrics is usually more about like the efficiency. If somebody comes to your platform and is searching for something, usually they want speed. They want to be able to find that thing the quickest. It's very different from somebody coming and staying on your home screen and scrolling. Like that's a very different type of behavior. So what you want here is making sure they don't spend much time. And so we measure this through time to successful search. And then obviously your top level company metrics. You could see this as like primary and secondary are your input metrics. And if these evolve in the right way, they should be moving your top level metrics, which are the outputs, conversion rate from search, and revenue per search are usually the top ones for search. Okay, so I know we're at time. I can stay a little bit more to answer any questions, but I know it was a lot of information. It was quick, but like I said, I don't know if you were all there when I said that. I've been recording because I have been asked if I could do that, and I will be sharing the slides as well. Yeah.
Thank you. That was a good session. Good overview of search for someone who doesn't know about search that much. I think that was very good. Thank you so much. I do have a question. For the quality of results of search that you were talking about on the metrics, is there a threshold that you normally say is good? And is that based off of something like, how is that measured or how is that even calculated? Something.
Yeah, so usually what we look at is, so first you have to define with your team what relevant item means. Usually the way teams do this is like users click on an item and they spend some amount of time on that item. So the previous teams I was working on, it was like if they spend more than 10 seconds looking at that product detail page, that means it's a relevant items. So that's like the first step is like finding what relevant item means. And then you take the ranks. So the way you calculate this is like you have all the items that the user has clicked on. They all had a specific rank. And then you define your own threshold on like when you decide to discount that rank. So basically what a lot of teams do, it's like either if it's not in the top 5 or it's not in the top 10, I'm going to discount the rank in that calculation. And then we normalize all of those ranks and we divide by what would be the ideal rank. So like in an ideal world, if I had my 10 first results were exactly what the user wanted and they clicked on it, what would be that score? And so that's the divider. And so usually, the closest you are to 1 from that on that metric, the better. That means you're very close to what a human would say is super relevant results. If you have a score of like, I don't know, 0.5, but again, it's going to depend on where you put the thresholds, right? But like 0.5, that means usually most of the results were on the second page.
Is that something that you collect from the user? Constantly a feedback?
Yeah, every time. So in search, usually you collect what you return and the rank of each item. And then on the click, when a user click on something, you also collect what they clicked on, like the item ID and stuff like that, but also the rank of that item. That's how you keep a trace of it was returned at this rank and the user clicked on it, and you could keep a track on that.
That's great. Thanks. Good to know.
Yeah, no worries.
Are the metrics different for like AI products that you were talking about, RAG or other hallucinations? Are they slightly different quality metrics?
Not really, because I guess you cannot really look at the quality the same way because there's no like rank. It's more there are other metrics that we also look at in search that are becoming more important because of the chatbot use case, which is like we used to measure like the research rate. So how many people are searching again after searching a first time because they're just not satisfied, right? And so in chatbots, that becomes a much bigger metric because that's the signal that tells you, okay, it didn't answer the correct thing.
Yep.
So I know there is that. I'm trying to think. Yeah, there is that. And then based on what the user re-asked, they do also that query understanding step. So like if they ask in particular about like the brand or the color or the availability, like whatever they ask about again that the bot has gone wrong, that's what they're going to use to feed back into the model. But that's more like the feedback loop and the retraining more than the actual like measurement.
Yep. Got you. Thank you. That's all I had. Anybody else have questions?
I know I threw a lot at you. I was
Yeah,
like,
everybody's really quiet.
45 minutes is a little tough, but
Hey, this was great. I need to drop off, but thanks for doing this. It was a good refresher for me.
no worries. Thank you for coming.
Yeah.
Of course. Bye.
Bye.
Yeah, thank you so much for hosting this. It was really helpful in kind of distilling complex and intimidating terms. So I really appreciated this. Thank you.
Yeah, no worries. Yeah, in the search teams like to make it look complex. There's a lot of terms and stuff, but like at the end of the day, it's just like concepts, and as long as you understand how it all works, I feel like that's actually what matters. If you don't know the actual terms, it doesn't really matter.
For sure. Thank you so much.
Yeah, no
Okay.
worries.
Thank you, Laura.
Thank you, Laura. This was very helpful. Really appreciate you taking the time to talk through this with us.
Yeah, no worries at all. Thank you for coming.
Thank you.
All right. Bye.
All right.
Everyone have a good weekend.
Thanks. Bye, everyone.